we met today with the offering manager from IBM for IZOTA. I'm remembering his name, Kevin Perry. And Bob was on the call. He got up very early this morning for the call. And the technical manager for IZOTA. And I outlined for them this outline. I said, listen, guys, there's interest in having, Geneva work with Spark. And as we've looked at it, Spark's a map reduce framework, but the map pass of Spark typically just breaks apart the file, repartitions the file in anticipation of being able to do the reduce phase and use the hardware efficiently in the reduce phase. Well, in GenevaERS, we want to do everything in one pass. So it would be an anthem to us to do a pass of the file where we didn't try to accomplish everything in that single pass of the file. So if you take these two and you marry these up, the reduce phase processes, if they're trivial, GenevaERS may be able to do them at the same time that it's making the pass of the file. You may be able to eliminate the reduce phase because you just do it in the map phase at the same time, however many there are, if they're not too complex. If they're complex, then Spark's data preparation phase of the map may lower elapsed time, but in either case, GenevaERS may be more efficient. But we all know that Spark has many more functions than we have in Geneva, right? Machine learning, statistical sorts of things, all sorts of libraries that are available to Spark that aren't available to us in GenevaERS, and would take us a long time to add those sorts of capabilities. My sense from talking with the IBM IZOTA team is that this resonated with them. Well, we've got an interesting kind of intersection there, talking about Geneva as map on the mainframe for the first, and us feeding to GenevaERS. So when we started some of this, we were talking about Spark integration using JSOS as a potential IO method. There was nothing we heard today that invalidated our ability to actually get that done. And Neil and I have improved in an interactive Spark session that this is possible to do. We didn't build the module and haven't made a program out of it, but we've technically proved that you can call JSOS IO for IO, sequential IO from Spark. We didn't get to the point of being able to call UR20, which we'd hoped to do, but we have a better sense of what it would take for us to get there. As we did the review last week, kind of trying to speed up here a little bit, taking a bit more time maybe than I should. On Friday, we said, listen, what we're trying to do on this JNI work and connecting up Spark so we could perhaps eliminate writing to an extract file and perhaps pipe directly from Spark or from MR95 thread to Spark. As we started to talk through it, boy, it got to, that's going to be a lot of work to figure out how to do all of that processing. Could we drop back and do something more simple? The suggestion Randall had already, I know he's been talking with you, many of the team in Australia about this already, about changing the extract file format or making a new extract file format, an optional Spark extract file format, perhaps, that's simply comma delimited with a header record. Spark would be able to read those kinds of files very easily. If we did that, then our intersection with Spark becomes simply the ability to execute Spark instead of MR88 as the reduce phase. I'm going to pause there. Did that make sense? Am I going too fast on that description, or is that clear enough?
Yep, that's cool.
Okay. Then I didn't get to draw this diagram, but what I wanted to draw as we talked last week, we said, listen, we could take the DDP functions that are MR88 functions, and we could try to translate those into something to execute Spark to do the things that MR88 typically does. The problem with that is if you do the Venn diagram of the the MR88 functions and the Spark functions, the only thing you can enable on Spark will be the common ones between Spark and MR88. It's going to be a fairly small set of things. So although it technically could be done, we don't think it has a big impact because the workbench and historical MR88 functionality don't incorporate all of the new stuff that we want to try to do in Spark. So where we kind of ended up last week that we were just going to talk over here in the group is where we want to ultimately go with our new user interface, our new workbench, and more the language approach is if we have the language approach to specification of GenevaERS processes, then we could enable Spark within that construct much more easily. It would open up the capabilities of things that we could have MR95 do, followed by Spark processes. I think the end result of that discussion is we want to think about what that looks like, what we start to do around that language, what we need to do from an R&D perspective for research sort of thing, kind of what Neil's been doing on the JNI side. Are there some things that we could do to start to inform ourselves as to what that is so that when we get to development, we're informed about what road we should take, and can we do that in small steps with little bits of time that we have to do some experimentation. One more comment just before I close up there and open it for discussion questions. We were given the access today. I don't know, Bob, if you heard back from Nicholas on the Spark side, but we're given for internal purposes on the internal IBM machine permission to use the latest version of Spark from the IBM development team. And they were interested in what we're talking about, happy to support us and want to further the discussion. Can see how a more open sourced version of Spark on ZOS, as opposed to that has now license implications, how making a more open source version of Spark can enable the kinds of work we're trying to do. So that's very good news that we got that successful meeting done today. Comments, questions on any of that?
So are you talking that MR95, well, Spark would replace MR88?
Yes.
And is there any way that Spark has an API that MR95 could call to, instead of landing the data and having Spark reread it in?
Yeah, that's good, Jeff. I think that's maybe step 2. That's taking IN's work on this JNI way further. But we need to inform our Spark functionality more before we start to get that far down the road. So we want to first do the simple process of landing files. But you're right, that's exactly where we want to go for efficiency, is we want to go to a piping mechanism between them.
Okay.
So not a language API such that Scala, Java, and I think
You're quiet again, Neil. You're near your mic.
Yeah, sorry. Is there not a language API that Scala, Java, and I think Python makes use of so that they can use their native languages to communicate with Spark?
Yeah. I think actually, Neil, based upon the conversation today, but actually this morning, Sandy and I started to do more research. I joined the Spark development Apache open source community. I just joined the email list today. So I'm starting to get emails from the Apache team, the Spark team. We need to grow our knowledge and intersection with that team. And it may be through these, through the IBM IZOTA team. If they're interested, they'll be able to help us translate much more rapidly. into what's possible in this phase. But doing our first round of file-based intersections will help inform what we do ultimately, I think.
Hey, Kip,
Yeah.
could you flip back to the prior slide, please?
Yes, this one?
Yeah, here. Okay, so at that original meeting where you got those 2 comments about integrating with Spark, was that something that the people just came up
Yes.
with, or had they been prompted by you?
No, that was that. I think I might have said something about Spark, but if you go to our Geneva TV, our YouTube channel,
Yeah.
you'll see that I put out there the video of an edited version of the TAC meeting.
Uh-huh.
It's this one. This was the edited version, GenevaERS proposal to the Open Mainframe project. It's 24 minutes. You can hear these comments within that if you listen to this video. It has the attendees. They went straight to. I think I said Spark as a way to them to understand GenevaERS, but they ran from there very quickly to say, oh, that sort of intersection would be very useful for us.
Mm-hmm. Interesting. Yeah, I remember, like, Kip, remember when we were in Poughkeepsie, I guess it was January of 2018 now, I had a good chat with distinguished engineer, I forget his name now, but
Yeah.
he said that, really, for us to get some notice, it would really be good if we would, like, partner up with some other product that was more successful
Yeah.
or more known out there in the community. And I thought a lot about that. And I think maybe this, well, I'm convinced this is the right one. I think we should do whatever we can to integrate with Spark.
Yeah, I think it gives us a real powerful story. They add things to our capabilities, and we add things to theirs.
Yeah. And
Excellent.
I think there are probably people that would help us do this.
Well, those individuals today sounded quite interested, I thought, in a conversation.
Yeah. You know, I had to take off at about the time you were telling them about the public cloud enablement thing. And what was their reaction to that?
They said, well, that's great. This is great. I don't know, Bob, what was your take? I don't know if you listened to the end. It was very early your time.
No, it was they were a lot more interested, and they were keen to explore it because I suspect they're open to anything really, which was really good.
You know, the interesting thing, Bob, Nicholas, who's the main product owner, he said, listen, I make a fix to Spark for a security leak that I notice, and it's buried in my code. I want to have that be part of the main code, is kind of the sense that I got he was saying. He wants to make bigger contributions back and wants his work that he's done. They've done wrappers, Randall, around Spark. So it's pure Spark code is how I took it, Bob. But they haven't made any modifications to the Spark open source code base, but they've added wrappers around the outside of it to deal with Big Endian and Epsidec translation processes. So that's kind of this PAX file that Bob is going to be given access to, contains both the Spark core code plus those other elements, and those other elements are still IBM licensed elements. They aren't yet fully, they aren't open source pieces yet, but they wanted to be participating in open source more directly, I thought.
That's great.
Okay, that was longer than I had anticipated it being, but I think it's a good discussion.